Hello friends, in this video I'm going to demonstrate the classical producer consumer problem in Java, and we'll also see how it can be implemented in Java. So first, see what is producer consumer problem. Okay, so the problem statement is like producer consumer problem is a classic synchronization and concurrency problem in computer science and software engineering. Okay, basically it involves two type of processes or threads referred to as producers and consumers, which share a common limited size buffer or queue. So the goal is to ensure that producers can add items to the buffer without overflowing it, and consumers can retrieve item from the buffer without accessing empty slots. So there are two threads. One is producer and second is consumer thread. Producer thread will produce the elements and insert it into the queue or that shared other or any shared resource, while the consumer thread is responsible for consuming the items from the queue. But a challenge arises from the fact that the producers and consumers can potentially interfere with each other's action. Okay, so producers need to ensure that they do not add items to the buffer if it's full. They might need to wait until there is a space, while consumers need to ensure they do not try to consume items from an empty buffer. They might need to wait until there are items to consume. So the actual problem, the challenge is that of concurrent programming, where multiple threads or processes interact and share resources. In real world scenario, you can compare this problem with the printer queue problem, where producers adding print jobs while consumers printing them. Similarly, in the kitchen, you can consider it like chefs are producing dishes while waiters are serving them. So now let's go to the actual Java code, like how we can implement this problem, producer consumer problem, and how we can handle this concurrency challenge there. Okay, so let's go to the IntelliJ and see it. Okay, okay. So here I am to my IntelliJ. So first of all, we know like there is a shared resource. So in this case, I have created a class that shared resource, and this shared resource I have implemented using queue, and I have taken the max size of the queue. So any producer will produce items in the queue, and any consumer will consume items from this queue. Okay, so that's why I have taken a queue and I have given a max size to it. So in the constructor, you can see like while creating an instance of this shared resource, I am creating an instance of queue. I am initializing queue with the, and the size I have taken the max size that I can pass while creating an instance of the shared resource. And in this class, I have defined two methods. One is produce and second is consume method. So, and you can see like I have made this produce method SS modified as synchronized. So it means that only one thread can access this method at a time. Okay. So what this produce method will do? So this produce method will check if the queue size, that is size of queue, is equal to max size. So in that case, the producer thread will wait. If there is a space available in the queue, then only it will add items. Otherwise, if it's full, in that case it will wait. And if there is a space, then it will add items to the queue and notify all the waiting threads. Okay. And then we have again another method that is consume. Again, this method is synchronized. So at a time, only one thread can access this method. Okay. Here the consumer thread will check whether the consumer thread is empty or not. If the queue is empty, consumer thread will check if the queue is empty or not. If the queue is empty, it means consumer need to wait, right? Because there is no any element present currently in the queue. So that's why consumer need to wait. Consumer will only pull the items from the queue or take any items from the queue if there is any item available in the queue. And after pulling the items, it will notify all the threads that it has consumed the items. Okay. So this was produce and consume method in the shared resources. After that, I have created two classes that is implementing runnable interface. So basically you can say that these are like threads while in sliding threads. So there are two classes, one is producer and another is consumer class. Both are implementing runnable interface. So both of this class has taken the reference of shared resources that is being passed to this class. Okay. And then we have overridden this run method. So basically what this run method do for the producer in case of producer. So for the just demonstration purpose, I have iterated it through the loop for 1 to 10 elements, and producer thread will produce the items in the shared resources. Okay. And then after that it will print that it has pushed the items in the queue, and so that's why it's that is produced, and the what was the number of items it has pushed into the queue. Okay. And after that I deliberately I have made it sleep for the 100 millisecond. And in the consumer class, again, it's implementing runnable interface. It also needs the shared resource. So that's why I have passed the shared resource in the constructor. And then I have ordinal run method. Here, it's consuming the items from the queue. Okay. And after consuming the items, it is printing consumed and the number. And again, it is also going to sleep for 200 milliseconds. Okay. And then, so that was the code part, like how we can implement it. Then in the, I have come here is the main class, like how we can test it. So for that, like I have, first I have created the shared resources. Okay. I have given the size of 5. And I have created 2 threads, that is one thread is producer thread and second thread is consumer thread. In both the thread, I am passing this shared resources. Okay. And then I have started both the thread so that it will inherently call the run method of producer and consumer thread. And finally, I have called the join method on both the threads so that both the threads gets completed. Only after that program gets terminated. Okay. So now let's run this program and see what happens. So after running the program, you can see that producer is producing the elements that from 1 to 10, while consumer is also consuming the elements. So there is no interference in the consumer and producer. Okay. So this way you can handle this producer consumer classic problem. So this is one way. Another way is also that you can use the blocking queue. In case of blocking queue, you do not need to write so many logics for the wait and like notify all, because it inherently it has the feature of blocking queue has the feature to handle concurrency and related challenges itself. Like it will not allow you to add elements if the blocking queue is already full, and it will not allow you to remove the elements if it's empty. So you can use the blocking queue. You can also use the reentrant log, or you can also create your own custom log. So those are other ways by which this problem can be implemented. But the core of this problem is only that you need to handle this concurrency challenge while implementing this problem. So that's it, guys. Thank you very much. If you like the content, please like, share, and subscribe. So thank you. Thanks a lot.